Hi, my name is Melissa Hunter. I'm a systems engineer here at NXP Semiconductor, and in this video I'm going to talk to you about the i.MX RT boot flow. The RT processors support a number of different boot sources, as shown in the slide here. Most of these boot sources require that the memory be copied from the boot source to a destination memory, either the on-chip system RAM or an external SD RAM. For two different interfaces, we support an XIP option, which is execute in place, where the application stays resident within the external memory and is not copied. The two interfaces where XIP is supported are Flex by NOR and the SEMC parallel NOR. The Flex by NOR is by far the most popular option for RT, so we'll be looking in more detail at what happens for a Flex by NOR execute in place boot. The RT ROM requires several different data structures to be included within your application image. At boot time, the ROM will read these data structures and use the information within in order to actually boot your application. This diagram here shows the layout for a Flex by NOR XIP boot image. Starting with the FCB here, this is your Flex by configuration block. This data structure is used to provide parameters to the ROM that the ROM will then use to configure the Flex by controller in the optimal configuration for accessing the Flex by flash. And it will always be located as the very first address within the Flex by region of the processor. Next, we'll have your IVT and boot data. The IVT is your image vector table, and it's really a list of pointers to other boot components. The ROM always looks for your IVT for a Flex by NOR boot at a 0x1000 offset from your base address, so that's what's shown in the diagram here. Then your IVT can have pointers to optional components such as your DCD. This is a device configuration data structure. This is optional, and you can use it for configuring SDRAM interfaces over the SEMC controller on RT devices. You can also have pointers to an optional CSF block within your IVT. This is your command sequence file, which is an optional structure that is used when booting authenticated code using the ROM's HAB functionality. There's the required pointer you need in your IVT and boot data is your pointer to your actual application, as shown here. Our SDK examples for RT are fully bootable images and include the boot data structures that are required for an application. I'm showing an example here with the RT 1050 Hello World project. There's an XIP folder, which is where all of the boot data structures are defined. Starting here, we have our Flex by NOR config, which contains the FCB. In this case, the FCB is configured for the memory that's on our EVK. If you're running this on your own board, you may need to make modifications to the FCB here specific to your memory. There's also an SDRAM DCD file for initializing external memory. Again, this is configured for the SDRAM that's on our EVK. You might need to make modifications if you're running this on your own hardware. And then finally, the NOR boot file here contains the IVT and boot data sections. Each of these files has defines that determine whether the boot data structure in question is included in the application or not. You can use the preprocessor define section of the project settings to include or exclude all of these boot data structures. If you want to run directly from the debugger and have a bootable image, you'll want to leave all the boot data structures in. If you are using some of our ROM boot tools, you may want to take these data structures out and have the boot tools add those files back in for you. This diagram shows the flow the ROM will follow for a FlexPy NOR boot. To start, the ROM's going to configure the FlexPy pins and the clock for a 30 MHz operation. Then it performs default read from the flash in order to read the FCB information. The default read that's used to get the FCB into the ROM is determined based on your boot configurations. The boot configuration can come from GPIO override values or fuses depending on your boot mode settings. After the FCB has been read, the ROM will then use the parameters within the FCB to reconfigure the FlexPy block for the optimal configuration specified by the FCB. Typically, this is going to increase the frequency so that the rest of the boot data and the application can be read in much faster. Then, the ROM is going to look at the IVT pointers. If IVT pointer points to a FlexPy address, the ROM knows that it's an XIP boot where everything's going to be left in place. If the IVT points to a different target memory, the ROM knows it's not an XIP boot, will copy the image to the target memory as needed. But for the XIP boot, there's no copying. Everything's left exactly where it is, and the ROM will just go to executing the image directly from its FlexPy location.
Okay, thanks for watching this video. For more information, please visit NXP.com.